What is up, most distinguished patrons of this channel? Today we are going to talk about something that's pretty frickin' sweet, and that is the fact that you can TIG weld on any stick machine, virtually any. So don't quote me exactly on that, virtually any. I got to say that for the lawyers. But what I have in this box is something that may work for you to where you can learn to TIG weld with very minimal equipment. And that's awesome. That's one of the great things about TIG welding. So let's talk about what's in this box. Let's get into it. So this particular accessory kit comes from No Welder. And in case you're wondering, that may be related to another company on Amazon, but I refuse to name them because they basically just get people to be shills for them. And I didn't get this provided by them. I bought it off of Amazon. And my recommendation is if you want something like what is in this box, go on Amazon, look at the reviews, and buy something that's decently reviewed, and you won't have any problems. So let's open this up and see what you get. So we have a accessory kit, and we have a TIG torch. And this isn't just any TIG torch. This is what's known as a scratch start TIG rig. And what I mean by that is it has this lug here that you clamp the stinger of your stick welder onto here. This is where your gas hookup is for your argon gas. And then on a torch, you have a valve that you open and close to start argon flow. And this gives you the ability to do what's called scratch start TIG on any stick machine. Now, I say any stick machine somewhat loosely because if you only have an AC buzz box like a Tombstone that does not do DC, unfortunately, this is not for you. If your machine is AC only, you're pretty limited. There's ways of doing a bridge rectifier on that to where you could TIG weld with it, but honestly, you're best off with some form of a DC capable machine in order to use this. This little dirt cheap stick welder, I paid $100 for this a couple of years ago, and it's dirt and it's cheap and it's borderline unsafe, especially with this cord here that came with it, where it has a 240 volt that you plug in the wall, and then your grinder and all your other accessories would love to run on 240 volt too. Anyways, this little janky stick welder is actually capable of doing what's called scratch start TIG with this setup. What you do is you hook the electrode holder, so your stinger, to this, like I said earlier, and then your ground clamp goes to your welding table or to the piece, and then you set your amperage just like your running stick, and then you can TIG. The problem is with setups like this, and well, by setups I mean not just this welder, but doing scratch start, is it takes a fair amount of skill to weld with it. And what I mean by that is modern TIG welders have high frequency start where you bring your tungsten close like this wire is to the table and you press your foot pedal and it initiates a high frequency, high voltage arc that crosses the arc gap, and then that's the pilot arc, and then the main arc starts on the back of that. So it makes it really easy to start. A lot of maybe older school machines or certain circumstances, you need to use lift start, where that is you touch the tungsten to the work and then you lift it immediately and the arc starts. So you have more or less like a lower voltage feeding through that tungsten. When the machine detects 0 volts, meaning that the tungsten's touching, and then you lift it, it sends a pulse that will cross the arc gap to get the arc started. When you use this setup, you're doing what's called scratch start. So just like you start a stick rod where you kind of scratch it and lift it a little bit, that's how you have to start the arc with this TIG setup. Another alternative, and that's the way I would recommend, would be to take your tungsten, get it close, and then scratch between it to where your filler rod touches the tungsten and the base material. That will likely lead to less contamination of your tungsten and make it a little easier to start, because what you have to understand is you have full power. So if this machine is set at 100 amps, you have 100 amps live, and the second you touch it, it's so common and so easy to just fuse that tungsten right to the base material, and now you're in a pickle. The other thing that you have an issue with scratch start is there's no way to taper off amperage. It's just fixed. So if you set the machine for 100 amps, that's all you're going to get is 100 amps. You're not going to get more, not going to get less. And you also, to basically end the weld, a little stiff, this is pretty cold in this tin shed here. As you're welding, you have to snap out of the weld. So you basically more or less quickly flick the tungsten off of it to where the arc can't maintain because there's not enough voltage. So it's a little bit harder, very much cruder than a modern TIG setup. However, for all you guys at home that are on low budgets or can't afford much and you happen to have some kind of a DC stick welder, this, for a very minimal investment, will give you the ability to make TIG welds, to learn how to TIG pretty cost effectively. Now, there's one other downside that I'm going to mention, or actually two, and then we'll get to actually setting this crap up and doing some welds with it. Another major downside of this setup is the fact that you're using a gas valve that you have to open and close in order to start and stop gas flow, means that you're likely going to waste a lot of argon. Now, when you get used to a setup like this, you're automatically, anytime you're done welding, going to be shutting the valve anyways. But let's say you were an idiot like I've been in the past and you leave it cracked or wide open. Next thing you know, your whole bottle of argon is going to be gone. And guess what? You can't just put it back in there from your garage or your shop. So you just blew through anywhere between, I don't know, 15 to $100 and some worth of argon. So it's a little bit more wasteful. Modern machines that do scratch start, or excuse me, lift arc and high frequency often have gas valves, so this is done automatically by the machine, not by you. So that's kind of a, I wouldn't say it's a crappy thing because this does work, you just have to remember to shut it. The last thing that's kind of a bit of a gripe about setups like this is a lot of the setups that are out there do not have flex necks like what this one does. And the cords, the cables are extremely stiff, and it tends just not, it's hard to do precision work. Now, this particular torch seems to be better than a lot of them out there, but my recommendation is to get a flex head and get one that has a decent review, and don't get one that's got a super stiff cable. I mean, this isn't too bad, honestly, but you got to watch it because some of those, like, it's almost like you're trying to take rebar and bend it, and it's just not effective to use. All right, I think you understand enough about that. I'm going to get this set up maybe with this stuff. I have other gas lenses and stuff I might end up using, but I'm going to get this all set up, and we're going to do some scratch start TIG, and I'm going to show you how well this actually works even with dirt cheap welders. Something about this doesn't seem safe. I don't know what it is. So basically your stinger just clamps on that eyelet there, and then this is now electrically live. So you want to be extremely careful that you don't just set this near your welding bench or on it, or things you don't want electricity flowing through, because that whole thing's electrically live. The easiest way to deal with that is to use a glove like this, cut a hole through it, slip it on that whole fitting there, and then kind of like this. And then when you clamp your stinger on, you just pull a glove down over it. Now, I'm not going to wreck this pair of gloves here. I'm just going to cover it because this is only going to stay hooked up for long enough to do this video, because I have no real reason to use scratch start myself because I have TIG welders that function with lift arc and high frequency. Anyways, I'm going to cover this and we'll leave that there, and we'll go up to the welding table and start welding. So here is the setup. I'm going to run a couple beads on this flat, clean plate here that's scrap from another video. And the gas is turned on. You can hear it. There we go. We got pretty decent gas flow. I'm running about 18 CFH. Realistically, for the amperage we're going to be running, I could run a little bit lower, but that'll work for what we're doing. And then, of course, you want to shut that off when you're done welding. Key tip regarding the whole torch valve situation: a lot of people see post flow as like a waste of argon, but you do need some post flow. If you just shut this valve off the second your weld is done, the tungsten will likely oxidize and it'll start getting nodules or the start of forming them, and then your arc is going to wander and not be as clean. So you want at least, I don't know, 3 to 5 seconds, depending on what size tungsten and what amperage that you're running at, before you just shut this off. So don't get in the habit of just, motor and on welding. Okay, let's immediately shut it off. You're going to contaminate your tungsten with oxides doing that. Not to mention, it does pay to keep post flow at the end of the weld a little bit longer. Now, in this case, because it doesn't automatically cut the arc out as we're welding, you're going to watch me snap out of it and then bring the post flow back close to kind of help shield it. Again, we're kind of limited with this setup, but at the same time, hey, it beats not having TIG welding. This is a pretty handy, really good process, TIG welding in general, to be able to do, especially on small parts or when you absolutely need a perfect root pass or something. Like, it's hard to beat. All right, well, I got to go fire up my generator, and I'm going to turn the heaters on, the portable house fire in here. It's like, I'm not joking, about 18 degrees. It's colder than shit. All right, I'll be right back. All right, so I got the machine set up at 100 amps. This particular machine is plus or minus about 20 to 30 amps from the set point, and that's pretty common with cheap machines. You can expect, when it comes to dialing in things, to be a little bit off. Now, for a thicker plate like this, which is probably like 6-7 millimeter, quarter inch, somewhere in that ballpark, it's really not a big deal, because you can TIG weld this at 90 amps and you can TIG weld it at 200. But where you're going to have issues with this type of a setup is on thinner material. Like, if your machine can't go below, say, 40-50 amps, like you got some DC tombstone, you're going to have issues TIG welding thinner material. You're also going to have issues as you approach an edge on a weld on thinner material. It's going to tend to be too hot and blow out because you don't have a foot pedal to back off with. So that's all things to consider with this. It's basically going to take more skill to do decent TIG welds, but it's not a bad way to learn, because you can get really good with the TIG process. It's just that it's easier to start, easier to terminate a weld with a more modern, less primitive rig, I guess. All right, I got the gas flowing. Let's start. All right, I'll turn that post flow off right now. When I started, there must have been mill scale or something on the corner of the plate. It kind of like popped and sputtered, but the gas shielding worked out really good, had no issues there. And once I made it past that edge, everything looked good. I can tell you that that is much hotter than 100 amps. And I remember when I tested this welder, 100 amps was more like 120 or 130. So that machine's pretty janky, but hey, it did weld and make a pretty decent weld at that. Now, I can tell you already, this torch, I'm going to have to do some adjustments on it, and I'm not going to do it now, but later. And what I mean by that is, when you see how this thing, positions, it's so stiff that it's hard, like it wants to stay here. Well, I can screw around with how the hoses run to get it in a better position, but what I'm really going to do is just spin the fitting down here later to where this is more in line. And that's, again, something you find with cheaper torches is, like, this would fatigue to hell. I mean, look at this, it's just spinning the handle. There's so much tension on that, but hey, it is what it is with that. But I'm going to run a couple more beads, and I'll try and get some arc footage of the start. It's going to be pretty tough because it just goes from, no ignition to lit, because I'm swiping between the tungsten and the work. So I know you're saying, well, that's cool, it can run beads on plate, but what kind of quality welds can you put down on maybe a fillet weld? So what I'm going to do now is do a root pass on one side and a root pass and a weave on the other, and I'll clean it up and then we can take a look at it. And I can tell you already that the TIG process, as long as you have an arc and you're running close to the correct amperage, you can put down X-ray quality welds even with a setup like this that, you know, in today's world probably costs about $200 to get set up, maybe a little bit more. And that's one of the awesome things with TIG, is that a cheap $200 to $300 setup is literally enough to do X-ray quality welds on basically unlimited thickness material. And that's something that you can't achieve with basically any other process as easily, in my opinion. I mean, stick welding can weld thicker steel like this without an issue, but the welds still, in my opinion, and well, I guess in reality, are not going to be as consistent as TIG. So it's a lot of capability for not a lot of money if you're willing to have the patience to learn how to do it. With that said, let me move the camera and let's get this sucker welded together. So I was successful in welding this fillet weld and didn't have too many problems. Now, when I hit the end of the first weld, I snapped and it was able to maintain a pretty long arc. So it kind of was arcing off to the table. That was my bad, but I fixed that on the next one. And what you're going to find with rigs like this with the old scratch start is, depending on the machine, it can be a little finicky, and getting the starts exactly perfect is a little bit harder than a modern machine. And then of course, when you snap out of it, it's very common to arc off on something else depending on what kind of voltage your machine can produce. But for the most part, the meat of the weld doesn't really look any different than what you would expect with a higher end TIG machine. And like I said earlier, doing it this way is just a little bit harder to start, a little bit harder to terminate a weld, but the actual welding of it is very similar. Now, again, granted, you don't have a foot pedal, but for a lot of things, it really doesn't matter, especially thicker steel. There's really no issue with this type of setup. Where it's going to be a struggle bus for you will be on thinner material. It's just going to be very easy to blow a hole. Now, there's a couple things I'm going to mention here. Again, the way that this is set up and how much tension is on this torch, it's extremely difficult to get it in a position that I would like. And that has a lot to do with how inflexible this cable is that's in here. And when you get into better TIG torches, you don't have that issue, and it just takes the load off your wrist. That was one of the major reasons why I was struggling on the first part of the weld. Was, you know, when you have that much tension on this sucker trying to get it where you want, it's no fun. So my honest recommendation is to find a torch with a gas valve and a super flex hose rather than buying a cheaper one like this. It'll be easier on you, but hey, I proved you can do it with this. Now, the other interesting thing, and I didn't notice it before, so that little cheap $100 stick welder, I'm almost 99% positive has some AC or choppy AC on the output. I have never heard a TIG welding arc that had, it sounded like an AC waveform in it. Now, I didn't see anything that resembled AC TIG coming out of it, where like electrons are coming out of the piece to the TIG tungsten, but the arc sounded like it had hints of AC. So again, the reason I bring this up is that a cheaper welder, I did decent welds with it, but the way the puddle was reacting was a little bit odd. It's a noisy arc, and it's not something I would want to do every day, to be honest with you, especially over, you know, a better DC power source than that. And luckily, it doesn't take much more welder than that $100 welder to get to something that's probably a little bit smoother of an arc. Now, as far as, you know, how much metal you can really put down, there's the, ooh, that's hot, weave and a root pass. There's just a root pass. One of the things you got to remember if you're going to try and do a setup like this cheap is that your duty cycle is going to be pretty trashy, to be honest, when you start talking 130, 140 amps, which is the max that that machine can output. And I was at 100 amps, but from what I remember, 100 is like 130 amps with that machine, and anything above 110 is maxed out, like there's no difference. So if you have plans on TIG welding out a whole bunch of stuff with some cheap welder and this type of a setup, you can forget about it. You're far better off with, like, I don't know, a DC Tombstone or a Dial Art 250 or some other machine with some decent duty cycle if you're trying to do this. You know, some 100 amp stick welder is probably not the right one to be using this with. But anyways, realistically, this is a very viable option, and for a lot of you, it's affordable. The main downside, besides what I mentioned, really comes down to the cost of getting a bottle of argon. When you're used to going to the store and just picking up a box of rods, you know, for 30 bucks for 10 pounds, and you don't need any gas cylinders or anything, that's really kind of cost effective, right? Well, guess what? If you want to start TIG welding, you really should get at least a 150 cubic foot cylinder, preferably a 300 cubic foot. And a lot of those are unfortunately $300 to $500. So the $300 to $500 fee is more or less to buy the tank that's full, but then when you swap it out with your local supplier, you're only going to pay a fill fee of, like, I don't know, $60 to $120 for a 300 cubic foot tank. So yes, the initial investment is high, but in the long run, it pays off. So realistically, if you have a DC stick welder and you pick up one of these TIG torches for probably anywhere between 100 and 200 bucks and get yourself a 300 cubic foot cylinder somehow of straight argon, for a fairly reasonable investment, you're adding a tremendous capability in your arsenal, and that is TIG welding. And it's fairly cost effective getting the bigger cylinder, and you got to practice to get good. You can't just, you know, lay down great looking welds with TIG with no practice. So it's always practice, practice, practice. But it is cost effective, and it might be an option for some of you that you would like to get into, and you might be able to use the equipment you already had, just as you saw in this video. You don't need fancy stuff to do this. So with that said, if you got any comments, questions, thoughts, feel free to leave them. Until next time.